I will now work through the backside of the Chapter 6 Quadrilateral Review. So the first section asks us to list every quadrilateral with the given properties. So not just the one with the best name for it, but every quadrilateral. So the first one is congruent diagonals. So first of all, with parallelograms, if they have congruent diagonals, that will make it a rectangle. And anytime you have a rectangle characteristic, that means that characteristic is also true for a square. But now if we go outside of the parallelogram family, this is also true when you have an isosceles trapezoid. Next one, perpendicular diagonals. So if it's a parallelogram and the diagonals are perpendicular, that makes it a rhombus. And if it's true for a rhombus, it is always true for a square as well. But outside of the parallelogram family, perpendicular diagonals also occur in a kite. Opposite sides are congruent. So the opposite sides are congruent in every parallelogram. In fact, that's one of the characteristics that makes it a parallelogram. And so if it's true for a parallelogram, that means that it is also true for a rectangle and a rhombus and a square. But because it makes it a parallelogram, it will not be true for trapezoids or kites. For congruent angles, well, in a quadrilateral, 4 congruent angles means it has 4 right angles. And 4 right angles is the definition of a rectangle. And if it's true for a rectangle, it is also true for a square. The next one says only one pair of congruent sides. So if it only has one pair of congruent sides, it cannot be a parallelogram. A kite has 2 pairs of congruent sides that are consecutive. And so the only one where this will always be true is for the isosceles trapezoid. The last one, 4 congruent sides. Well, 4 congruent sides is the definition of a rhombus. And if it's true for a rhombus, it is also true of a square. But because it's the definition of the rhombus, that means it cannot be any other quadrilateral. Right, next set. Are the following quadrilaterals parallelograms? If yes, explain why. So in this first diagram, I see that one pair of opposite sides is both parallel but not congruent. And so if those other opposite sides are not congruent, well then it is not a parallelogram. The next one, I see these markings, splits that diagonal in half. Splits that diagonal in half. So if the diagonals bisect each other, that is one way to show that it is a parallelogram. So yes, the diagonals bisect each other. The next one, I see the angles marked, the opposite angles are marked congruent, but not all 4 angles are marked congruent. Well, opposite angles are congruent, That is one way to show that a quadrilateral is a parallelogram. So yes, because the opposite angles are congruent. Next one, I see all four sides are marked congruent, which actually makes this a rhombus. Well, a rhombus is a type of parallelogram, so yes, it is a parallelogram, but really the parallelogram reason would be because the opposite sides are each congruent. So yes, it is a parallelogram because the opposite sides are congruent. Well, in the next one, opposite sides have the same measure. So once again, this is a parallelogram because the opposite sides are congruent. The next one. So here I have one pair of opposite angles, but I don't have the other pair of opposite angles. So the other property to check is, are the consecutive angles, are they both supplementary? Do they add up to 180? Well, 150 plus 30 is 180. 150 plus 30 is 180. Therefore, yes, because consecutive angles are supplementary. Down to the last row, I've got opposite sides that are parallel, opposite sides that are parallel. Well, that's the definition of a parallelogram. So yes, it is a parallelogram because the opposite sides are parallel. If I had more space, I would probably write that I had two pairs of opposite sides that are parallel, two pairs of opposite sides are congruent, two pairs of opposite sides are congruent, two pairs of opposite angles are congruent. That would technically be a little bit better answer. The next one, again, I don't have opposite angles, or both sets of opposite angles, but I have consecutive angles. 45 plus 130 is 175, not supplementary, not adding up to 180. So no, this is not a parallelogram. The last one, we got parallel sides, and they have a measurement that is equal. So yes, this is a parallelogram because one pair of sides is congruent and parallel. And if one pair is both of those things, then we don't have to know anything about the other pair. Right, we're ready for the next section. Which of the following are not polygons? Explain why you chose them. So, the first one is not a polygon, so I'm going to circle that because it is not a polygon. And the reason it is not is because it is three-dimensional. It is not two-dimensional, not 2D. You could also just write 3D. That would be fine. The next one, this one is a polygon. It's two-dimensional. It's a closed figure. None of the lines overlap, and there's no curved segments. Third one. This one is not a polygon because these two ends don't connect to each other. It is not closed. It is an open figure. Last one. It's closed. It's two-dimensional. No lines overlap. And there's no curves. So yes, that one is a polygon. The star-looking object here, it's closed. It's two-dimensional. There's no curves, no overlapping lines, so that is a polygon. The next one, it's closed, it's two-dimensional, but it has curves. And so because it has curves, therefore it is not a polygon. The next shape, it's closed, no curves, two-dimensional, no overlapping lines. That is a polygon. The last one is not a polygon because these lines overlap. They cross each other. There's sort of three different triangle shapes that make this up. And so this one, because the lines overlap, therefore this one is not a polygon. Okay, the next group. Label the following as equilateral, equiangular, regular, or none of these. So in the first one I see all four sides are marked congruent, but not all four angles. There's a different number of arcs. Well, if all four sides are the same length, that is equilateral. The next one, all three sides have different markings, so it's not equilateral. All three angles have different markings, so it is not equiangular. So therefore it is none of these. Third one, all three sides are congruent, so it's equilateral. All three angles are congruent, so it's equiangular. And if something is both equilateral and equiangular, that makes it regular. And the last one, nothing is marked on the sides, so I don't know if it's equilateral. All five angles are marked congruent, therefore this one is equiangular. And the last one. Draw the polygon described in each box. Convex hexagon. So convex means there's no indentations. Hexagon means it has 6 sides. There's no other rules besides those two. No indentations. It's got 6 sides. So I'm going to start drawing 1, 2, 3, 4, 5, 6. Doesn't say anything about regular, equilateral, equiangular, so 6 sides, and it's convex. Concave pentagon. So concave means it does have an indentation. Pentagon means it has 5 sides. So I'm just going to start drawing my sides. 1, 2, 3, 4, 5. Here's my indentation. There's the diagonal that would be outside of the figure. There are 5 sides. Concave pentagon. Regular quadrilateral. Regular means both equilateral and equiangular. Equilateral quadrilateral means that it's a rhombus. Equiangular quadrilateral means it's a rectangle. And if it's both a rhombus and a rectangle, therefore it is a square. So I'm going to try to draw it as nicely as I can, but more importantly, I'm going to mark it as being regular. So all four angles are marked congruent, and all four sides are marked congruent, making it both a rectangle and a rhombus. Equilateral convex octagon. So octagon has 8 sides, and it's got to be equilateral. All 8 sides have to be the same measurement. I'll do the best I can here. I know that an equilateral octagon that's convex looks like a stop sign. So I'm going to try to draw a stop sign. 3, 4, 5, 6, 7, 8. Okay. But if it's equilateral, I need to mark it so that even though my drawing isn't perfect, if I show that there are 8 sides that are all congruent to each other, that makes it equilateral convex octagon. Concave dodecagon. So it has the caves, the indentations, but dodecagon is 12 sides. So I'm just going to start zigzagging. I need to be careful not to make the lines overlap. But I'm going to get my cave. 1, 2, there's at least one cave. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 sides, so it's a dodecagon. Concave, there's multiple places here where I have indentations. Lots of different possibilities there. And the last question, equiangular. So all the angles are equal. It's a septagon. That is a slightly less common version of heptagon. If it shows up on a test, we'll use the word heptagon rather than septagon, but both of those words refer to a 7-sided figure. So trying to draw a 7-sided figure that's equiangular. So that's going to be a little bit challenging for me, so it's going to be important at the end to mark all my angles congruent. So I'm going to see what I can do. 1, 2, 3, 4, 5, 6, 7. I've got 7 sides, so I don't know how well my angles turned out, but I've got 1, 2, 3, 4, 5, 6, 7. None of them are drastically different from the others, so I feel pretty good about that. But I marked them all as being congruent, and I've got my 7 sides. Therefore, that qualifies as an equiangular septagon or heptagon.